Lesson 69 today is about factoring trinomials. And when we factor a problem like this, x squared minus 14x minus 15, when we're factoring trinomials, we just have three terms here. Now, what we're doing is we're essentially doing the opposite of multiplying binomials. And when we multiply binomials, remember, that might look something like x plus 3 times x plus 4. And in order to do a problem like this, well, we'd use the FOIL method. The first numbers, x times x, that's x squared. Then we do the outer numbers, that's going to be plus 4x. Then we do the inner numbers, plus 3x. And then we do the last numbers, 3 times 4, that's plus 12. When we simplify, we get an answer of x squared plus 7x plus 12. And that would be our right answer if we multiplied these binomials. When we factor trinomials, we're going to do exactly the opposite. So we're going to work from the end, and we're going to come back to our beginning. Let's do that here. So, in order to do that, we set up our two binomials below. And then we're going to get x times x. We need to have that in front, because x times x is x squared. Then what we need to do is we need to figure out a pair of numbers that will multiply to negative 15, and that will add to negative 14. So we're going to write that out here. The numbers have to multiply to negative 15, our last term, and they're going to have to add to negative 14, our middle term. And specifically, they're going to have to add to negative 14x, but the x will take care of that for us, just like it did when we did our original problem. So if we look at some different numbers that will multiply to negative 15, but add to negative 14, we've got to look at what we're going to multiply first. And the ways we could get to negative 15, there's only a few. We could say negative 15 times 1, or we could say 15 times negative 1. And this is all going to be to the multiplication part right here, and it'll work downwards. Or we could say 3 times negative 5, or we could say negative 5 times 3. Now when we look at these four choices, do you see any one that will add to negative 14? Well, hopefully you do. Hopefully you saw 15 times negative 1, because 15 plus negative 1, that's just equal to, well, 15 plus negative 1, that would be 14. So that wouldn't be the right answer because we've got to add to negative 14. Hopefully what you saw is this one, negative 15 times 1, because negative 15 plus positive 1, that's negative 14. So that's essentially our answer. So we're going to say x, then we're going to take the minus 15, and then we're going to take the plus 1. And this would be our answer for this problem. So we're looking for that combination of a pair of numbers that will multiply to our outside number, our constant, and will add together to our inside number. Now we can check this answer to make sure it's right. X minus 15 times x plus 1, and let's see if we got it. If we got it, it should come back to what we had originally. X times x, that's x squared. X times 1, well, that's just 1x. Negative 15 times x is negative 15x, and negative 15 times 1 is negative 15. When we simplify, we get x squared plus x minus 15x, that's negative 14x, and then we have minus 15. That's exactly what we started with. We got our answer right, and we can check it using that FOIL method in order to make sure we did. Let's look at some more. Here we've got a factor, x squared plus 3x minus 10. So when we factor, we're going to get two binomials for our answer. We're going to have x and x out front, because x times x is x squared. Now we've got to think of what multiplies to negative 10 and adds to positive 3. So to get to negative 10, we could say negative 10 times 1, or 10 times negative 1. Or we could say 5 times negative 2, or we could say negative 5 times 2. Do you see the pair of numbers that will multiply to negative 10? Has to be one of these four, but will add to positive 3. Well, hopefully you saw this one, 5 and negative 2, because 5 plus negative 2, that's equal to 3. And that's exactly what we want, a 3. So we've got our answer now. We put our 5 in first, x plus 5. We put our negative 2 in second, so negative 2. And we're all done. We've got the correct answer. When you can use that pattern in order to solve, you're going to get it right each time. Let's look at another one. Negative 5x plus x squared plus 6. Now this problem's tricky because whenever we do these, we want to make sure we have the problem in descending order of the variable. So let's rewrite. We want the x squared out front. Then we're going to have minus 5x. Then we're going to have plus 6. So we know our binomials, when we factor, will be x and x out in front because x times x gives us x squared. We need two numbers that multiply to 6. So we could have 6 times 1, or we could have negative 6 times negative 1, because that's also positive 6. Or we could have 3 times 2, or we could have negative 3 times negative 2. Now this one, there was a hint. There was a hint that the answer is going to be one of these two with the negative numbers. And the hint that the answer is one of these two with negative numbers is that our middle number is negative. If the middle number is negative and the outer number is positive, well, the only way you could multiply and get a positive answer and add and get a negative answer would be to have two negatives. So which one is it? Is it negative 6 times negative 1, or is it negative 3 times negative 2? Hopefully you said negative 3 times negative 2, because negative 3 plus negative 2 add to negative 5. So we can go ahead and write those in. We've got x minus 3, then we've got x minus 2, we've got our final answer, we can box it, and we're all done. Now you might be wondering, does it matter if the negative 3 goes first or second? And the answer is no. You could have also written x minus 2 times x minus 3, and that's full credit as well, because it's exactly the same answer. We've got one more. And notice this one's also a little bit tricky because it's not in descending order of the variable. So we're going to x squared, and then we're going to write the x first, so plus 6x plus 5. Now in order to get to 5, and it must be positive numbers because our middle number is positive and our outer number is positive, we can say 5 times 1. And that's our only choice. And it works because 5 plus 1 is 6. So our answer is going to be x plus 5 times x plus 1. And we've successfully factored this trinomial. Let's box it and continue on. Lesson practice will be on page 283. Make sure you've got your notes complete, and I'll see you during our next class.